Hi everyone, I hope everyone's having a great day. This is going to be your pre-lab lecture for TLC and Column Chromatography. As a reminder, this is an in-person lab for Group A and Group B. Group C is completely online. So for Group C, this video is going to help you with your pre-lab notebook, but for your conclusion and all that stuff, I can definitely explain that. I can explain you that through office hours or through email, or I can send you a video personally just explaining that. I just want Group A and B to really understand their conclusion during lab, so I'm going to be explaining that to them in lab. As I said, Group C, I will contact you. Okay, so before your lab day, make sure you read the lab manual, annotated, get good notes out of it. Once you think you got that down, make sure you watch this video, and the video I'm going to post as well, which is the one I'm recording right now. Alrighty, for your pre-lab notebook, make sure you bring your pre-lab notebook to lab. If you do not have your pre-lab notebook, I can't let you in because your pre-lab notebook has your procedure, and it has your experimental hazards, and it has your purpose. So I need to know that you guys have read the lab manual, you guys understand what you are doing. You don't want to just be mixing chemicals. So make sure you bring that. You're not allowed to bring your lab manual. You can't use it. So anything that you want to use has to be on your pre-lab notebook, and it has to fit the guidelines for your pre-lab notebook. And that's pretty much all I have for it. Please don't forget it. It will break my heart if I have to send you guys back because you guys don't have it. So please don't forget it. Print it out, bring it to lab. That's what you're going to use. Okay, your pre-lab quiz. Pre-lab quiz completely composed of TLC questions. If you understand your lab manual, if you have seen these two videos that I posted for you, if you're watching the video that I'm showing you guys right now, you should be definitely fine for this quiz. No worries. Okay, when you get to lab, this is what you're going to see. This is going to be your lab bin. Now, if you have a cracked glass, let me know. If you're missing glass, also let me know. That way we can go back to the stock room and we can get you a new lab bin or some glassware. Okay, this lab is going to be done by Group A the week of September 14th through 18th, which is this week. You guys are going to come in first. How exciting. And then Group B is going to be completing this the week of September 21st through 25th. So you guys, Group B will be doing recrystallization first, and then TLC, and then Group A is going to be doing TLC first, and then recrystallization. So Group A, after this video, go ahead and watch recrystallization. And if you're watching and you're from Group B, you already did recrystallization, so get ready to come into lab for TLC. And Group C, like I said, I will contact you, but if you're watching this video, you should be definitely fine. I will contact you for a post-lab. Okay, your post-lab notebook. Everyone's post-lab notebook is going to be due on Sunday. Remember that you are working on different labs depending on your groups. So if you're working on recrystallization, turn that one in on Sunday. If you're working on TLC, turn that one in on Sunday, depending on your group. And for Group C, this is the data you want to be using. If you think you understand it and you want to get ahead of the game, go for it. I'm still going to contact you just in case. Alrighty, let's get started with a PowerPoint that I made for you guys. This PowerPoint is going to emphasize concepts that I want you guys to know because you will get tested on the final and on your quizzes. So I just want to help you guys a little bit more just to understand the material. It is material that is repeated from your lab manual. I got it out from here. So I just hope that you guys get a little bit more understanding out of it. So yeah, okay. So chromatography is a variety of separation techniques widely used for analytical and preparative purposes. All methods of chromatography operate on the principle that all compounds of a mixture will distribute unequally between two immiscible phases. Now we have two immiscible phases. We have the mobile phase, which is comprised of a liquid or a gas. It could be either or. And we have a stationary phase, which may be a solid or a liquid. Now the mobile phase flows continuously over the fixed stationary phase, and we're gonna see how it flows over it in a little bit. Immiscible phases, like I said, we have two. Individual components have different affinities for mobile and stationary phase. A dynamic equilibrium is established in which a component is selectively but temporarily removed from the mobile phase by binding to the stationary phase. When the equilibrium concentration of that substance in the mobile phase decreases, then it is released from the stationary phase and the process continues. Each component partitions between two phases with different equilibrium constants. These are our partition coefficients. The components separate into migratory bands. I will show you the migratory bands in a picture right now. The component that interacts with or binds more strongly to the stationary phase moves more slowly in the direction of the flow of the mobile phase. How I like to think of it is the stationary phase is kind of sticky, and if we have a sample going through it, if it's interacting with the stationary phase, it's going to move more slowly because it's kind of stuck to the stationary phase, you know? So it can't really flow in the direction of the mobile phase, so it's going to go slower. But if it's not really binding to the stationary phase strongly, it's going to move further, okay? TLC, it's a form of solid liquid adsorption. It's important in organic chemistry for rapid analysis of small quantities of sample. This is important, the small quantities part, because we will see that column chromatography is different in this way from TLC. A limitation, it cannot be used on volatile compounds having boiling points below about 150 degrees Celsius. How TLC works. Now I want to show you guys this picture really fast. These are your migratory bands. As you can see, this is very different from what we're going to do in lab. I just wanted to kind of show you the bands in a different color so you can kind of see how they look like. This is kind of like a mini scale lab. So very different from what we're going to do. We're going to use a beaker and a watch glass. How TLC works. So a small amount of sample is applied to a solid absorbent. The solid absorbent will be the stationary phase. So like I said, remember, sticky. The plate with a spotted end down will be placed in a beaker covered with a watch glass, and this will be our developing chamber. The chamber contains a saturated atmosphere of a suitable eluent or eluting solvent, which is the mobile phase. May be comprised of a single or mixture of solvent. This is referring to the eluting solvent. It's important to note that the solvent must be below the placed dot. So I don't know if you can really see in this picture, but you have dots right here, and the eluting solvent is way down here. Now, it is already starting to move up. That's why it's kind of by the spots. But the eluting solvent was from the beginning below the dots. So it's super important that you guys do this when you come into lab. Okay. The solvent will begin to ascend the plate. The individual components of the sample are carried up the plate with the eluting solvent based on the relative affinities, like I said. For the solid adsorbent, more weakly adsorbed compounds move up the plate faster than those that are more strongly adsorbed. Each component will then appear as a separate spot on the plate, and your TLC is completed. This is the first part of your experiment. Oh, sorry. Adsorption to the stationary phase. Adsorption to the stationary phase involves the strength of adsorption of organic compounds to the stationary phase of the TLC plate depends on the polarity and nature of the adsorbents and the type of functional groups present in the compounds. So if you have substances with carboxyl groups and other polar functional groups, it's going to be more strongly adsorbed. So these are going to be like the sticky ones that are going to want to stick to the stationary phase. If you have less polar substances with alkenes and alkyl-halides, they will be less absorbed. Effective eluting solvent. So it is very important that we use an effective eluting solvent, and these are some ways to find out how to pick a correct eluting solvent. So the eluting solvent must readily dissolve the solute but not compete with it for binding sites on the stationary phase. Solvent should not be too polar because it may bind strongly to the adsorbent and force the solute to remain in the mobile phase. It must be significantly less polar than various components of the mixture to obtain an effective separation. Eluting power. The relative ability of different solvents to move a given substance up a TLC plate. This is just a picture that is on your lab notebook, and I just decided to include it. Okay, how to visualize the separated components in a mixture of TLC. There is many ways to do it. We're going to use a specific way in lab, and you guys are going to see that on Wednesday. Compounds that fluoresce located by placing the plate under a UV light. The spots should be circled because if you take the UV light, you can't really see them. So they should be circled with a pencil just to keep record of them. A plate may be sprayed with reagents to produce color or dark spots, or it could be exposed to iodine vapor, and the spots may become brown. Retention factor. This is something that you guys are going to be calculating for your post-lab calculations. So make sure your retention factor equation is on your pre-lab calculations. The retention factor value for a compound is a physical constant for a given set of chromatographic conditions. The adsorbent and the eluting factor should be recorded along with the experimentally determined RF values. Now, this is how you calculate it. RF is equal to distance traveled by substance divided by distance traveled by solvent. As you can see here, we have our origin. Now, this is the distance traveled by our substance, the 2.1. And then you have to calculate the distance traveled by solvent. So you go to the origin and you calculate the solvents. And then you divide 2.1 by 2.8 to get your RF factor. You may have more than one substance being divided. So make sure you if you have two, make sure you calculate for the two of them, because then you're going to get it wrong. And I'm just giving you a hint for that because you're going to have to calculate 2 RF factors per plate. So it's just a small little hint before we start lab. But I will explain more about this during lab, just in case you guys don't get it. This is just a preview. Okay. Column chromatography. It's another form of solid liquid adsorption. The advantage over TLC, like I said, there is an advantage to this. Multi-gram amounts of mixtures can be separated. The disadvantage, it requires considerably more time to perform. So when you guys come into lab, you guys are definitely going to see that column chromatography takes a lot more time, and it is very hard to clean this one. It takes time to clean it. So you guys also have to make sure that you clean as you go, because we don't want to stay the whole entire time. So make sure you do that. Okay. Oh my God. Process of column chromatography. This is the same as me trying to explain the TLC chromatography, but there is different components. So a multi-component mixture is dissolved in a small amount of appropriate solvent and applied to the top of a packed column containing a finely divided active solid absorbent that serves as a stationary phase. Next, the eluent, which is the mobile phase, is passed down the column. Individual components of the mixture will move downward with eluting solvent. They will travel at different rates depending on the relative affinities for the packing material. And more weakly adsorbed compound is eluted faster from the column than its more strongly adsorbed compound. So this same rule applies to TLC, and the same rule for TLC about it being more adsorbed applies to column chromatography. So just keep that in mind. Individual components collected in separate containers. I will explain more about this in lab. And solvent is removed from each fraction by evaporating to provide the pure components. Okay, this is something that was provided by Dr. Rastogi. If you want to use this, you can add this to your pre-lab calculations, and that will be completely fine with me. I feel like this picture is really good in demonstrating how to follow your procedure. So if you guys want to add that, I'm completely fine with it. Just make sure you understand what is going on in the picture, and you don't just put this picture and not your procedure. You still need your procedure. Okay. Adsorbents used for column chromatography. Alumina and silica gel are used, but we will be using silica gel. Both of them are polar. Silica is slightly acidic. Silica is good because the quality of adsorbents is high. They have uniform particle they have uniform particle size and high specific area, so that is really good. Normal phase column chromatography versus reverse phase column chromatography. Okay, this is something you definitely want to understand. You're going to get quizzed on and you're going to get tested on, so please understand this. On the left, I don't know if you guys are seeing the left or the right, but on the left, normal phase column chromatography has a polar stationary phase, such as silica gel, which is what we're going to use, and it is used in combination with organic solvents as a mobile phase of eluent. Now, the reverse phase is literally the opposite. Packing material for stationary phase consists of glass beads coated with non-polar hydrocarbon film. Now, for normal phase, we would have a polar stationary phase. For reverse, we now have a non-polar stationary phase. Mixtures of water and organic solvents are used as eluting solvents. Non-polar organic molecules are more strongly attracted to the non-polar stationary phase. In normal phase, polar would be attracted to polar. Polar solutes are more strongly attracted to the mobile phase. More polar components of mixture eluting more rapidly than the less polar ones. It's literally complete opposite of normal phase chromatography. I just need you guys to understand that concept, that they're opposite to each other. Wet pack method. This is what we're going to be using. They discuss a different pack in the lab manual, a different method in the lab manual. But I'm showing you guys that we're going to be doing the wet pack method. So this is one of the ones that I definitely want you to understand. They may ask you what is a different method too, so make sure you go over that as well. The column must be constantly tapped as the solid settles through the liquid to ensure even form packing of the adsorbent and to remove any entrapped air bubbles. We do not want any air bubbles. Liquid level in the column should never be allowed to fall below the top of the adsorbent. If bubbles occur, channeling will occur, which will result in pore separation. And like I said, we don't want pore separation. I will discuss this in the lab because obviously this is part of our procedure. So it's going to be more easier in lab when I explain everything. Okay. Stepwise or fractional elution. Series of increasingly more polar solvents is used to elute the mixture from the column. Non-polar solvents such as petroleum ether, which is what we're going to be using, is used to move the least polar component of the mixture down the column. Then, polarity of elutant is increased using either pure solvents or combinations of mixed solvents so that the bands are individually eluted from the column. How to monitor our progress. We will collect fractions of equal volume. They're going to be 5 milliliter fractions into little test tubes. That way we know how we're doing and if we actually did something correctly. Fractions containing different bands may then be easily identified by the relative amounts of solute in each flask. On the day of lab, TLC will be used to determine correct polarity of solvent to start and end with. Column chromatography will then be used to separate fluorine from 9-fluorinone. And after chromatography, evaporation of the solvent at periodic intervals. And that is basically it for your pre-lab. If you guys have any questions, please let me know. Like I said, I just want you guys to understand the concepts more than anything having to do with the procedure. Everyone's going to do it in lab. I'm going to explain everything in lab. So I don't want you either panicking, but I do want you to know what's going on. So if you have to refer to this and to your procedure, by all means, go for it. Please understand it. Dr. Stogie also posted a video for the silica gel and column chromatography. So I would definitely watch that. I felt like it helped a lot. If you have to use more resources, also use that. Like I said, this is a very lengthy lab. And I just want you guys to be prepared for it. I hope this PowerPoint helped. I'm going to try to be setting up office hours. I will probably send out a poll to do that. If you guys have any questions, send them to the group me, and that would be it. I'll see you guys on Wednesday.